We are moving into lesson 2.2 today, and we are going to be talking about real numbers. So understanding real numbers, we have three vocab words here. The first one is rational numbers, and those are all numbers that terminate or repeat. So terminate means they're going to end, so they stop. Or they can repeat, which means they continue going on forever. So examples are 3/4, -5, 0.3 repeating, which is the same thing as 1/3. Those are all rational numbers. Okay. Irrational numbers are all numbers that don't terminate. So make sure you notice that word don't there. So they don't end or they don't repeat. So examples are pi and the square root of 5. Pi goes on forever, but it never repeats. So that's why it's an irrational number. Same thing with the square root of 5. It's not a perfect square. So if I take the square root of it, I'm not going to get a whole number answer. So that makes it an irrational number. So if I gave you the square root of 25 and asked you if that was a rational or an irrational number, the square root of 25 can be simplified down to 5. So that would actually fall under a rational number. So make sure you look to see if you can simplify it first before you notice, oh, it's got a square root, it's got a radical symbol, it's automatically irrational. That is not true. All right, and then real numbers is all of our rational and all of our irrational numbers. So that is the name for all of them, and then they're broken down into two categories called rational or irrational. Here is the real number chart. I really suggest pausing the video and writing this for your notes because when you have to classify numbers and things like that, you're going to definitely need this chart. Okay, so let's talk about the yellow circle here, natural numbers. Natural numbers are also called counting numbers. So if I asked you to count to 10, you would start at 1 and continue on saying all of the whole numbers up to 10. So those are natural numbers, and they continue on. Whole numbers are all those natural numbers, but now they've included 0. So whole numbers are positive whole numbers, and then including 0. Integers are all those numbers we've talked about so far, but now we're going to add in negative numbers. Okay, still no fractions or no decimals. Now we've added in negatives. And then we move to the rational circle, the lighter purple circle, and notice those include all of the circles that we've talked about so far. But now we've added fractions and decimals. So rational numbers are fractions and decimals, as well as the whole numbers and the integers and the naturals. And then all of those guys are real. Okay, and then over on the right-hand side, we have a little circle here with irrational numbers. Irrational numbers can only be irrational and real. So those were the ones that don't end, don't terminate, but they also don't repeat. Okay, so those things like pi or the square root of 2. So those are all of the different types of numbers that you're going to talk about today in your homework. So moving on, classifying numbers practice, we have to classify each number. So the first one is a -5. So if I go back here and I look, what's the smallest circle that -5 can fit into? And that would be integers because that's where the negative numbers started. So -5 fits in the integer circle. The integer circle is also inside of the rational circle, and the rational circle is inside of the real whole rectangle there. So -5 is actually an integer, a rational number, and a real number. So you're going to, when you classify, you're going to have to write all of them. So integer, rational, and real. 0, if I go back, I just moved all of that, so I'm going to have to erase it. All right, 0, if we go back up here, 0 is in our whole number. oval or circle. And whole number is inside of integers, integers is inside of rational, and rational is inside of real. So whole, integer, rational, and real. So whole, integer, rational, and real. Negative square root of 10. Can I simplify the square root of 10 and get a whole number? No, I cannot. So this is automatically an irrational number. And irrational numbers are also real numbers. Okay, negative 8/17. If you go back to the chart, fractions started to and be included in here in the rational numbers, and rational is also real. So negative 8/17 is rational and real. 8 would start at the natural number. So it's actually all of these going straight up. So natural, whole, integer, rational, and real. So natural, whole, integer, rational, and real. Negative 12. First time we see negative numbers would be in integers. Integers are inside of rational, rational is inside of real. So integer, rational, real. And then 3, that looks like the 3 times the square root of 2. We cannot simplify the square root of 2, so that is automatically irrational and real. So notice they're all real. They all fit into our chart somewhere. But if you find the lowest circle or oval that they fit into and then work your way up, it's included in everything above that. All right, these are the properties of real numbers. The commutative property says that if I'm adding or multiplying, I can just switch the order and I'm still going to get the same answer. The associative property says I can switch the order, but with grouping. So it's going to have parentheses. So they're telling me that I can add or multiply two numbers, a certain two numbers. So for instance, in the beginning there, it's B and C. I can add those first, then add A. Or I could flip it around and add A and B first and then C, but I'm still going to have the same answer. Same thing goes for multiplication. The distributive property is where I take that number outside and I distribute it in. So I have to multiply it by both terms inside of that parenthesis. So I have A times B and I have A times C, and then I have to add those together. The identity property says for addition that if I add a number to 0, I'm going to keep that number. And for multiplication, it says I can multiply any number by 1, and I'm still going to get that number as an answer. And then the inverse property is just talking about opposites. So if I take a number and add its opposite, I'm going to get 0, or its inverse, okay? And then for multiplication, it's saying that I can take a number and multiply by its reciprocal, which is just a flip of the fraction. So if I have 3 is really 3 over 1. They're telling me that I can flip that and multiply, and I'm always going to get 1. Okay, so those are the properties. Might be a good idea to have those in your notes. And then a closed set. So a set is closed if the result of the operation on any two numbers in the set is also a number in that set. So that's kind of confusing in words. So let me show you an example. Hopefully it'll make more sense once you see it. So it says determine whether the set -1, 0, 1 is closed under addition. So what they're telling us is that I can take these numbers and add them together because they're telling me we're doing addition. And I should get, if it's closed, I'll get my answers will be in this set. So if I start with this -1, I'm going to do -1 plus 0, and I'm going to do -1 plus 1. So basically I'm going to add each number together. I have to make all the different pairings here. And then if I have 0, I can do 0 plus the negative 1, and I can do 0 plus 1. And then that 1, I have 1 plus negative 1 and 1 plus 0. If I go through and actually figure out the answer to all of these, that's negative 1, that's in my set. Negative 1 plus 1 is equal to 0, that's in my set, so that's good. 0 plus negative 1 is negative 1, that's in my set. 0 plus 1 is equal to 1, that's in my set. And 1 plus negative 1 here is 0, that's in my set, and 1 plus 0 is going to give me 1, and that's in my set. The other things that we have to go through is we have to go through and add each number plus itself. So negative 1 plus negative 1, 0 plus 0, and then 1 plus 1. So if I do that, I get negative 2, this I get 0, and this I get 2. When I do that, these negative 2 and 2 is not in my set. So this is not closed under addition because we ended up with that negative 2 and that positive 2. I have one more example here. Show that the set of irrational numbers is not closed under addition. Find two irrational numbers whose sum is not an irrational number. So it's under addition, so we're adding. And we're talking about irrational numbers. So they want us to prove that it's not closed. So an irrational number would be pi. And they're telling us that if I add pi to another irrational number, I should actually get a rational number. So I want to prove this. So what can I add to pi that's going to give me a number that comes on the other side of our real number chart? So maybe I could do negative pi. So pi plus negative pi would actually give us 0 because remember, a number plus its opposite is always going to give you 0. That was one of the properties we talked about. So 0 actually falls into the whole number category in the real number chart. So this right here proves that this is not closed under addition because 0 is not in our set of irrational numbers. And here is a kind of a cheat sheet, if you will, of the number sets on what is closed and what isn't. So if they give you a set of real numbers, it is going to be closed under all different operations. So addition, subtraction, multiplication, and division, it will be closed. Irrational numbers will not be closed under any of those operations. And rational numbers will be closed under addition, subtraction, multiplication, and division. And integers will be closed for addition, subtraction, and multiplication, but integers will not be closed for division. Okay, so that's kind of a cheat sheet of if it's just a set of all real numbers or just a set of all irrational numbers. It's not specific numbers that they're giving you. This is kind of going to help you out and fast track you through that work.